Welcome to part 7. Thank you.
Yeah, with the main control board in place, the changeover board in place, the next thing is to move the transformer and the MOSFET. The next thing is to move it into the inverter. So just hold on. I just moved it in and I'm even yet to knot it down. I'm going to knot it down into the casing. And if you remember, I told you the MOSFET driver board, I like to have it facing this place, is because it will allow me to plug in the MOSFET to this place, and I don't want it to be far away. If it was standing like this, it would be too far away. That's why I prefer it to bend towards the MOSFET. So I think everything is inside now. The next thing is to make DC connections, battery plus, battery minus, and some other wiring. Thank you. Welcome back, guys. As you can see, the inverter is almost ready. Don't forget the H bridge, the MOSFET driver, the changeover board, the filter capacitor, they are all in place. The last thing I mentioned was checking to make sure that every of the board voltages are okay. So now I've checked the voltages, they are okay. I've plugged in the LCD. This socket is meant for the LCD. The socket for 12 volt input, like I told us, 12 volts coming from the battery through the current sensor. After the current sensor, it gets to the bridge, then the same 12 volts plus or minus is transferred down to the control board. So this is the slot for the LCD. So I'm slotting in the LCD now. The LCD is in place. Temperature sensor, this is the temperature sensor over there. I had to change the initial temperature sensor because it was faulty, so this is a new one. So this is the cable, this is the cable for the temperature sensor. So I have the temperature sensor in place. Then for the current sensor, this is the cable for the current sensor. I told us the cable, this is the same cable here. It runs through the fan. You can see through the front of the fan, and it's plugged in. Then the driver, MOSFET driver board needs power. So this is the power for the MOSFET driver board. And I think every connection has been made now. The fan has been connected. The driver signal too. The MOSFET driver signal has been connected also. So I think the inverter is ready to go. So look at the switch. This is the switch. This is the position for the switch. So I think all is set for the testing now. So next thing we're going to do is to bring some batteries. I'll bring some batteries here so that we may test the inverter. Thank you. Okay guys, I will be testing the inverter one more time. I've disconnected the battery positive, so I have to connect battery positive. I have to connect the knob. So battery positive is in place. The next thing is to check for the AC. Okay, the AC load, the 200 watt bulb, it's in place. So and that's the bulb. I have a meter here. It's measuring the current coming into the inverter. So let us see what we have at the inverter screen. The inverter says battery is 12.5 volts, 12.56. Temperature is 33 degrees C, and that's what we have at standby. So let me push this button to turn on the inverter. I'm pushing this button, the inverter should come on. Okay, here we go. The inverter is on. Let's see what it has to say on the screen. Battery now 12.12, load is 16%, frequency is about 49, and the watt is 100 and is fluctuating between 180 and 200. Okay, the frequency is 50 hertz. I think the meter is trying to stabilize. So output voltage 221, frequency 50 hertz. Then the current, let's take note of the current now. DC current is between 13 and 16, and let's see what the ammeter has to say. Okay, on the ammeter the DC current is approximately 16 amps. This is a 200 watt bulb. It's a load for testing. Okay, so the temperature is now 35. If you observe the screen, the inverter temperature has risen to 36. So the fan should come up with half of its speed when the temperature gets to 40 degrees. That's when the inverter is starting to heat up. So the fan will start with half of its speed. At the moment, about 16 amps running through the DC point. It's enough to make the inverter temperature to climb. And the temperature is now 38 degrees. So I'll wait and let us see what happens immediately the temperature. Let's try to observe the fan and the temperature reading simultaneously. When the temperature hits 40, the fan should pick up. Okay, that's what I'm saying. The fan is now spinning at half of its speed, like I said. So the inverter is not really hot, but it's trying to warm up. That's why the fan has to come up to cool it down. So as you can see, let's see what is happening on the temperature. It's dropping already. It's back at 36. So if it should get back to 35, the fan would go back to idle position. So the fan just stopped spinning. That is to confirm the temperature has dropped back to 35 degrees. So the inverter is working already. Thank you for staying tuned. We made the inverter together and we are testing it together as well. So I think what is left is to cover the inverter up. This will be the casing front. So this place will be covered using this plastic. Okay, the fan just kicked in again because temperature has gotten to 40 degrees again. Running this 200 watts load on a 12 volt inverter causes the inverter to reach the temperature of 40 degrees quicker than when we are running the 200 watt load on a 24 volt or a 48 volt inverter model. That's where the advantage of voltage comes in. If you are making a higher voltage inverter, it takes a while before the fan kicks in when you are running loads around 200, 300 or even 400 watts. So that's the work of the temperature sensor. Without the temperature sensor, the main control board wouldn't be able to know when to turn on the fan and when to turn it off. So the system is running continuously with about 16 to 18 amps, and the battery voltage is on 12, now dropping to 11, and the output voltage is steady at 221. So let me disconnect this load and see what the output voltage will be. Load has been disconnected. Let's see what the inverter is saying. So the output is still 221. The frequency is between 50 and 49. Probably it's 49 point something, that's why it's having approximation stuff. So the DC current presently has dropped down, so the wattage too has dropped down. The temperature sensor has kicked the fan into operation again, so I'm expecting the temperature to drop and the fan should permanently be off because the load has been disconnected. Okay, the fan has finally stopped and the inverter is using about 1.5 amps thereabout to run itself, 1.5 thereabout, and the running power is between 18 and 23 watts. So one thing I would like us to observe is that the output voltage is kept within a close range. It did not drop, neither did it went up. It did not go down. It's just approximately is moving around 220. The minimum we've observed is about 219 and the maximum being 221. So it's one of the features you should watch out on the inverter. The frequency and the voltage is very important. Let me put the load again and let's see. Okay, so the inverter has regulated back to 221. Immediately I fixing the load, I think I saw a little drop to about 208, but the inverter is able to respond as quick as possible to bring it back to 220 thereabout. Thank you. I think the video is long enough, so I decided to leave the inverter system open like this so that you can see how it's actually working, so you can see the internal components. The next time I'm recording, the inverter might have been closed and properly packaged. Thank you. Welcome back, guys. So the inverter has been covered, the entire casing has been painted. So I want to carry out other tests on the inverter before it's going to be delivered. So as we know, the DC connectivity is behind, then the AC connection has been made with the red wire and it has been converted to a socket. So I have two loads here. I have the 200 watt bulb and I have this 650 watt drilling machine. So let me put the inverter on first. Okay, the inverter is running with 1.6 amps. On the clamp meter is showing 1.6 amps, and let's see what we have on the main inverter screen. On the main inverter screen we have 1.9 amps, 23 watts, 221 volts, 50 Hz. So let's plug in the 200 watt bulb. Okay, there we go. That's the 200 watt bulb. Let's see what the inverter is saying now. Okay, the wattage is 186, 15.4 amps, 50 Hz, 219 volts. Let's see what the ammeter is saying. The DC clamp meter is saying 15.3 amps. Okay, the reading on the inverter is quite consistent. So let's now test the drilling machine by removing the 250 watts. Let's remove the 250 watt bulb. Let's test only this drilling machine.